1, no. All right, great. All right, so this section is on piecewise step and absolute value functions, but we're just going to focus on piecewise. Okay, what's a word that we recognize in piecewise that might help us contextualize? Anybody? Piece. So piecewise is saying that between a certain window, you may have one function, and you're just looking at the function within that window. The next window might have a different function, and the next window might have a whole different function. So it's pieces. Each function is kind of pieced together to make one whole graph. Okay. So I want you to look over here, and actually I'll just move this. Front row seat. All right, that'll work. All right, so we have this situation. Now it says g of x, we have this bracket here, right? What this is saying is g of x equals x plus 5 within the window of x is less than 2. So there's two pieces of information for each of these lines. It's saying y is equal to x plus 5 when we're looking at the window of x being less than 2. Okay? So watch what I'm going to do here. I'm going to go ahead and count this out. 1, not 1. Let's go 1, 2. This is negative 2. 1, 2. That's positive 2. So what you're going to do first is you look at these inequalities. And looking at this inequality, what is the important number? What is an important number at with those inequalities? What do we see? X is less than 2, we get this function. When x is greater than or equal to 2, we get this function. So what number is like a pretty key number in that? 2. So watch, this is what I'm going to do. I am going to make a boundary. Just make a boundary like that. So the two windows we're looking at is over here, less than 2, and on this side when it's greater than 2. I'm looking at those two windows. Okay. Now, which one of these functions goes in x is less than 2? The linear one. Okay. Now watch what I'm going to do. Function used to go all the way past this line forever. Used to go forever. Instead, it just goes there. All right. It's going to continue going in that direction. But I cut it at 2 because that's where the function goes. If it's less than 2, we have this linear function. All right. Now, let's go ahead and just move this over for convenience. I'll say it's like right here. Now, when x is greater than or equal to 2, we're using this function, which isn't exactly, I'm going to add it. It's a shift, so it would be x plus 1 squared. Don't worry about this. This is just an example. So watch, what I need to do for this function, where should I cut this function off? We're not interested in this function when it's less than 2. We're only interested in this function when it's what? When our x values are greater than 2. So our x values are greater than 2 on this direction. So watch what I'm going to do. I'm going to go in here, keep this so it doesn't fall. I'm going to cut it right here. Love these scissors. Okay. So I know that this function continues. The parabola, we're just looking at it within the window when it's greater than 2 from here over. And now we have our two functions on the board, cut into the windows that we're interested in. What kind of dot goes right here? It's on the very top right of the board, way over there. When it's less than, what kind of dot? Open. Okay. When it's equal than, or less, greater than or equal to, or less than or equal to. You see how this symbol just has more ink? I had to use more of my precious ink for my markers on this, right? Okay. Because this could be equal to, that's when we use a closed dot. When it's just less than, that's where it's open dot, because it doesn't include the actual value right there. So watch. Open dot. See it? The parabola, though, right here, it says x is greater than or equal to 2, so what should I put as far as where that function meets this 2 line? What should I do? What should I put here? That should not be, that should be the easiest question of the day. I'll say again. Here's our inequality for x plus 2. It's x is greater than or equal to 2. So with this function, what happens at 2? Is it going to be open dot or closed dot? Closed dot. Thank you. Thank you. It's closed because it could be equal to. This was open because it cannot be equal to. It's just going to that point, but it doesn't include that point. Okay. This is all there is to a piecewise function. That's all there is to it. We're going to do it now with steps. So let's look at our steps on the very right side. We're going to do this first example. Actually, we'll look over what's on the board first. So here, if you look at your inequalities, it's as if you have 3 different functions up here. You do. You have y is equal to x plus 2 when, right? This is almost right here. This is like when you ask this stuff right here. This is like when, right? Y is equal to x plus 2 when x is less than or equal to -1. Okay. So that's why if I was doing my dashed line, I would do a dashed line right there at -1. And this x plus 2 is the red part of that. You see how it just goes up to -1. It doesn't go past it because the window I need is just to -1. What's this one say? Y is equal to 1 when x is between -1 and 1. So that tells me I need another dashed line. So the function y is equal to 1 is just a line going horizontal at y is equal to 1, and it's between -1 and 1. You see the green line? Okay. Last. Y is equal to x squared when x is greater than or equal to 1. So I go over here to +1, and that's where the x squared, that's where that continues, the parabola, just on that side, though. Okay. So it's cutting it up. The when, well, when does it happen? Y is equal to x plus 2? Well, when? When x is less than or equal to -1. So you got to kind of like piece it together that way. All right. Let's look at example 1, and then I'll see how we're doing with this one. Okay. All right. Tell your neighbor if you have a neighbor next to you. Tell your neighbor, where am I going to put my dashed lines? Where is it important to put the dashed lines? Tell your neighbor. For this problem, example 1. Tell your neighbor. Sure. All right, let's see. You guys finished?
I'm done. He's doing the last one.
Really? It's amazing. So basically, if you're motivated, you can do the work.
Oh, you can do anything you except for this one isn't for the cross. Because all of these don't intersect.
I'm missing dots. Where's your dots? So based on this should be an open dot for this one. Where it's -4. This function here should be closed dots because it could be equal to it. So these lines, that's actually essential. It's not correct unless there's the dot. Yeah? Hmm? All right, let's see. May. Hey, May, where should I put my dashed lines? Okay. At -2, because that's an important part of the when does this happen. I'm going to put dash line. At 1, I'm going to put a dash line. So I have a window here, here, and here. Okay. We have 3 different functions we got to place into each window. Okay. So this is what you should consider. Y is equal to 4 when x is less than or equal or less than -2. So what? I'm going to go up here to 4. At -2, I'm going to put an open dot and the line just going to the left. This function right here is y is equal to 4. But I'm only looking at it when it's less than -2. Have fun. All right. Next, between -2 and 1, I have this function right here. And you'll be able to graph it with Desmos for the latter half of the problem here. But let's go ahead and do it right here. Y is equal to 3 minus x. And let's do a table for it. So how about somebody tell me what x value should I plug in? I'll say it first. Should I put an x value of 7 in there? Should I see what happens when x is equal to 7? That's a good question if you didn't hear me. So we're doing this function right here. With this, when does it happen? Should I put in and see what happens in this function when x is equal to 7? Why or why not? No? Why not?
Because there's no...
Close?
Yeah.
Okay. Blake, why not?
Because 7 is not a value between -2 and 1.
Right? Look, 3 minus x only occurs between -2 and 1. So what number should I put in there? I should put in -2, -1,
0.
and maybe 1, or 0 would be fine. I'll do 1 as well. So I'll do 1 for every point within the range that, or within the domain that's interesting here. So -2 in here, 3 minus -2, it's a negative, we add them, we get 5. -1 in here, 3 minus -1, 4. Put a 0, 3. Put a 1, 2. So you can use a table to graph anything, remember. You can use a table. So now watch. I'm going to do this in a different color. So this function, which is between -2 and 1, that goes with these points. So I'm going to go ahead and do it when x is -2, y is up here at 5, or -2, 5, -1, 4, 0, 3, 1, 2. I look here and I see that it's both going to be closed dots on either side of this function because it could be that -2, it could be the 1. So watch. The reason I made a closed dot is because it could be equal to those values. Let's do our last function. This function right here, we're going to do this one in blue. Let's do it. Y is equal to x. That one's quick, right? What are 3 numbers I should put in there? What are 3 values for x I should look for?
2.
2.
3.
Wait, I want to do another one other than 2. Why do I want to do another one that is definitely important? I definitely want to do this other number.
1.
1. Because? When does it happen? It starts happening when it's greater than 1. So let's see what's happening at 1. Let's see where that number is. 1, 2, 3. Let's see. Plug in 1 for x. What do you get for y? 1. What do you do when you plug in 2? Y is 2, 3. It's just one of those lines that goes at a 45-degree angle because it is equal to each other. So watch. I'm going to go here and at 1, 1, I'm going to put an open dot. 2, 2, 3, 3. There's the other part of that function. Why did I do an open dot? What do you think?
Just keep on going.
Because what?
You can just continually go.
It will continually go because it is a linear function, but specifically y at 1, do we have an open dot? Not here.
Because y equals x, you can just keep it going up and also x can be greater than 1.
Just
So
greater than.
anything greater than 1.
Anything greater, but not including 1 for that.
Yeah.
Good. That's what I said. Right. Okay. So we have open dot here. We had closed, closed. We had open based on the inequality. That's pretty much what we have to do every single time. Okay. Let's see. Thumbs up, sideways, down for the small class. Yeah, you try a couple. Try a couple. Okay. Use tables. The first 2 you have to do on your own. The last 4 you can use Desmos. So there's 6 problems altogether. And you can work in groups. All right. Nice short lesson.